In this video, we are going to do linear repeated again, but the problem is little different because instead of x and dx, we have sin phi and cos phi and d phi. Okay, so let us first convert it into polynomial form. You know what did they say for substitution? Derivative of any function is ready in the numerator. I am searching. I have cos phi, which is the derivative of sin phi. So what is the substitution? Sin phi is equal to t. And when I differentiate both sides with respect to with respect to phi, cos phi d phi is dt. Okay. Now what do I substitute for cos phi? I know sin phi is t. So cos phi is nothing but, I have actually cos square phi only. Cos square phi is 1 minus sin square phi, you know. So 1 minus t square, I am going to substitute in cos square phi place. So what happens to your integral? 3 times t, because sin phi is t, minus 2. Okay. And what is cos phi d phi? Cos phi d phi is completely dt. So this is cos phi d phi, that is dt, divided by phi minus, what is cos square phi? Cos square phi I got as 1 minus t square, because you know cos square phi is 1 minus sin square phi, and 4 sin phi is 4t. Okay. So now when I simplify this, I get integral 3t minus 2 dt, and when you simplify the denominator, it is t minus 2 the whole square. Okay. So when I simplify the denominator, I get t square minus 4t plus 4, which is nothing but t minus 2 the whole square. Okay. Now, do you understand? It is numerator is of degree 1 and denominator is of degree 2. Therefore, it is a proper partial fraction and it is linear repeated because t minus 2 the whole square is there. So let us complete it now. You know 3t minus 2 by t minus 2 the whole square is equal to a by t minus 2 plus b by t minus 2 the whole square, because if it is repeated linear, it is a by t minus 2 plus b by t minus 2 the whole square. So when I take LCM, I get 3t minus 2 is equal to a into t minus 2, because there is t minus 2 already here. The t minus 2 whole square is the LCM. For b, nothing is going to come because t minus 2 whole square itself is the LCM. So when I substitute t is equal to 2, because this will become 0, so I get b is equal to 4. And as I told you, if you do not have anything to substitute, just randomly substitute some value. For that I always use t is 0. So negative 2 is equal to negative 2a plus b. In this, if you plug in the value of b, negative 2 is equal to negative 2a plus 4. This implies a is equal to 3. Now I got the value of a and I got the value of b. What is a? A is 3 and b is 4. Whenever you do it in the exam also, you put a rectangle like this and keep it ready. So when you are going to substitute, you don't need to search inside. So this is nothing but I is equal to the given question. Okay, because I don't want to write it again, I write it as I is equal to undo. So the whole term is simplified as a by t minus 2. What is a? 3 by t minus 2 plus b by, b is what? 4 divided by t minus 2 the whole square. So it has now reduced to the form for which you know the integration. Okay. Now what is 1 by t minus 2 integration? 3 will stay outside. For t minus 1 by t minus 2, the integration is log of modulus t minus 2 plus 4 into, as we did already in the previous session also, when t minus 2 whole square in the denominator becomes t minus 2 whole to the power of minus 2. For this, the integration is t minus 2 whole to the power of minus 1 by minus 1. So this is 4 into minus 1 divided by t minus 2, because this is minus 1, t minus 2 comes to the denominator and then plus c. Okay, now this is same as 3 times log mod t minus 2 minus 4 divided by t minus 2 plus c. When the question is given in terms of phi, you are supposed to give the answer also in terms of phi. Okay, so I am going to substitute for t. What is t? T is sin phi minus 2 as it is minus 4 by sin phi minus 2 plus c. You know the value of sin phi is always less than 2 because sin phi lies between negative 1 and positive 1. Minus 1 less than or equal to sin phi less than or equal to 1. So if I don't want the modulus, I can rewrite it as brackets 2 minus sin phi because it is positive. Because it is 2 minus sin phi, I can make it as plus and write 4 by 2 minus sin phi because they look similar. That's all. No other reason. You can even write sin phi minus 2 for the second term and stop. But here you have to convert the modulus thing and write because you know sin phi minus 2 is definitely negative. Therefore, you should write it as 2 minus sin phi and then stop. This term you can even say 4 by sin phi minus 2 is also okay with a negative sign in the front, or you can put a plus and say 4 by 2 minus sin phi. So the sign gets adjusted. Okay. Hope it is clear for you.